we have a four-digit number A, B, C, D, and it's made out of some of the odd digits, 1, 3, 5, 7, and 9. But only four of them, so we need to just pick four and leave the other one out. The question is, how many different ways can we do this? So there are lots of different permutations, but can we do it in like a quicker way? The official solutions do it in a nice, concise way. I'm going to show how I did it. So I focused on the 5 to start with. So let's use the 5. If we use the 5, then it has to go. And by the way, when I write these solutions, I'm not writing them exactly how I would if I was doing the actual competition, because you have to show you're working clearly. It's I'm just trying to be concise, say the main things, but you would fill it out a bit more. So if we use the 5, it's going to have to be at the end. That's the sort of thing I would then write down. And then we need to think about what the other ones could be. Now, there are divisibility rules. Well, obviously, 1 goes into every number, so that's not going to be a problem. 7's a bit awkward. 3 and 9 have divisibility rules that we could look at. So let's use the 9 as well. Okay, we can think about where this goes. But at the moment, my sum is going to be 9 plus 5, which is 14. And then I need to make it a multiple of 9 as well. And if I add on, well, what have I got left? I've got 1, 3, and 7 left. So I've got, I could look at the different combinations, or I could add them all on. 4 plus 7, 25. Think, what do I then subtract to get a multiple of 9? The only one's going to be 7. So if I use 9, then I also need 1 and 3. So, you know, don't include 7, because that is how I'll get a multiple of 9 overall. So I could do, but then there's no problem actually, because if it's a multiple of 9, it will also be a multiple of 3, and it's necessarily a multiple of 1. So I could go 1, 3, 9. But I could look at the different permutations of this. Remember, 5 has to be at the end, and it's not actually asked us how many there are, but there's going to be 3 factorial. When you have A, B, C, there are 6 ways to arrange this, because there's 3 ways you can pick the first one, then 2 ways for the second, and 1 way for the last one. We call this 3 factorial, which is 3 times 2, or 6. So I can write all these down. So just systematically work through it. 193, and I'll put 3 first, go with 19. I don't know why I'm underlining them at this point, actually. Then we could have 391, or we could have the 9 first. Hey, so these would all be absolutely fine for the property that we're describing. Now let's stick to, we're still using the 5, but now we're not going to use the 9. Then we still have to have it end in 5, and we're left with 1, 7, and 3. So if I add all these up, 1 plus 7 plus 3 plus 5, then I get 16, which is not a multiple of 3, which is what we have to have it to be for the number overall to be divisible by 3. So there's no extra solutions here. So I've gone through all the possibilities where I'm using 5, and actually all I'm left with is when I don't use 5, so 1, 3, 7, and 9. So all that was kind of in one little section. I just had 2 cases within the using 5. So that can be 1, A, B, and now case 2. Not using 5. So we've got 1 plus 9 plus 3 plus 7, and that is equal to 20. So that's not going to be divisible by 9 or 3. And therefore, we're not going to get any extra ones here. And we've gone through all of them. We've gone through when we have 5, and then the two cases, and then when we don't have 5, it just doesn't work. So this is not like a model solution as such, because obviously I've been speaking over the top of it. So if you just kind of write a little bit more to your solution along those lines, then that is a solid solution for this question. Like I said, the solutions do it, the official solutions do it slightly differently, but this also works quite well. Let me just write overall, there are 6 solutions. Okay, actually, we're asked to list all of them, which I've done. Here, I just wanted to highlight it at the end. See above.